Okay, today's lesson is going to be the continuation of Chapter 0, Section 5, which was Systems of Linear Equations and Inequalities. We've already done the linear equations, so now we are going to do the inequalities. To solve a system of linear inequalities means that we're going to find all of the ordered pairs that satisfy the inequalities. Now, just so you can recall, you've done this before. An inequality might look like this. You might have a dotted line, and it's going to be shaded somewhere, probably, who knows, below it. And then you're going to have another dotted line going maybe this way. And it's going to be shaded above it. And the solution to this is actually where the two shaded regions intersect, which is over here. So this should look familiar to you. So go ahead and write down the steps to solving linear inequalities. The first step is to solve each inequality for y. And the reason for this is that we want to find m and b, which stand for slope and y-intercept. And the reason we need m and b is so that we can, step 2, graph each inequality, shading the correct area. For less than or equal to or greater than or equal to, we're going to use a solid line. So whenever you have an or equal to, you use a solid line. For less than or greater than, you're going to use a dashed line. The third step is to identify the region that is shaded for all of the inequalities. So this is where there's shading for every inequality included in the system. And the fourth step, and this is very important, is to check the solution by using a test point from the shaded region. And I'll show you more what that means in a moment. Here's your first example. We're going to solve the system for y greater than 0.5x minus 3 and y less than negative 2x plus 7. So my first inequality, the slope is 0.5, which is better known as 1/2, and the y-intercept is negative 3. So I'm going to go ahead and plot my y-intercept at negative 3, and I'm going to apply my slope to that, which is 1/2, which means up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to go ahead and draw a line connecting that. And it's going to be a solid line because it's or equals. And because it's greater than or equal to, I'm going to look at my y-intercept and I'm going to shade above that on the graph. So let's go ahead and shade above that line. My next inequality, the slope is negative 2 and the y-intercept is 7. So I'm going to go ahead and plot my y-intercept at 7. And I'm going to apply my slope. My slope is negative 2, but remember slopes rise over run, so it's negative 2 over 1. So I'm going to go down 2, right 1. Down 2, right 1, down 2, right 1. And before I draw my line, I need to check to see what kind of line I need to draw. And I need to draw a solid line. So I'm going to go ahead, draw my line, and now I need to determine which area I'm going to shade. So it's less than, so I'm going to go to my y-intercept and I'm going to shade below the line. And I want to go where the blue shading and this dark green / black shading intersect. And if you look at that, you will see very plainly that they intersect in this area right here. So this whole area is the solution. Literally, this picture is the solution. So if you recall, step 4 told us to choose a point in the shaded region as a test point. So you always want to try and choose something really simple, like, I don't know, maybe 0, 0 if it's in the shaded region. 0, 0 is in the shaded region. So my test point now is 0, 0. And I am literally going to plug that into both of these inequalities to make sure it works. So my first inequality is y is greater than or equal to 0.5x minus 3. So I'm going to plug 0 in for x and 0 in for y and see if it works. So 0 for y times greater than or equal to 0.5 times 0 minus 3. 0.5 times 0 is 0. Bring everything else down. And 0 minus 3 is negative 3. And my statement right now says that 0 is greater than or equal to negative 3. And the good news is you can just look at a number line if you have trouble with greater than and positive and negative numbers. So if you look at a number line, 0 is greater than negative 3 because it's to the right. So that one checks. Okay, let's go ahead and check the other one. Y less than or equal to negative 2x plus 7. I'm going to plug 0 in for both. Negative 2 times 0 is 0. Bring everything else down. 0 plus 7 is 7. And is 0 less than or equal to 7? Why, yes it is. So our solution is correct. Go ahead and try the following. Okay, here is the solution. As you see, this one was a little bit challenging. The solution is all the way over here. That is where the two graphs intersect. I chose a test point of negative 11, negative 16. Both of my lines were solid, and that would be it. Okay, we're going to do another example. I feel it's kind of important, so let's go ahead and look at this. Y is less than 3x minus 8, and y is greater than 3x plus 4. Okay, in the first graph, my slope is 3 over 1, and my y-intercept is negative 8. So let's go ahead and plot that. Negative 8 and 3 is my slope. Up 3 over 1, up 3 over 1. Gonna go ahead. Whoa, I messed up already. Before I draw that line, I need to check my inequality symbol. And it is not an or equals to. So that means it is going to be dashed. Your line should look something like that. That's not a very good dashed line, but you get the point. And y is going to be less than that. So I'm going to look where my y-intercept is, and I'm going to shade below that. So I'm going to shade down here. And your shading can be as simple as scribbling. It works for me. On the next graph, my slope is 3 over 1 once again, and my y-intercept is 4. So I'm going to plot my y-intercept at 4 and apply my slope to that. So I'm going to go up 3 over 1. And remember, if you run out of room and you can't do it again, you can do the opposite for each. So instead of going up 3, right 1, I'm going to go down 3, left 1. Down 3, left 1. Before I make my line, I'm going to check to see if it's solid or dashed, and it is going to be dashed as well. I need to work on my dashed lines. And y is greater than that, so I need to shade above the y-intercept. I need to shade up here. Okay, and now the next step is to check the region, identify the region where the shaded regions intersect, and they don't. So this one's fun. There is no solution. These are our favorite kind because our work stops here. Okay, go ahead and try this one. Okay, here's your solution. I want you guys to see that this area that I'm highlighting right now is the region where both inequalities were shaded. And I chose a test point in that region. I chose the point -3, 0. And it worked for both. Your assignment is on page P22, and you are to do 38 through 48 even, but you are to do them in class. Okay, just the notes are the homework. See you tomorrow.